Hello. Again, this is the This Week in R presented by the Hong Kong R User Group. And today is 27th of February 2017, and I'm Chainsaw. And again, the production quality is not good this week because I'm so busy during the weekend, and even today I'm not feeling very well. I'm still recovering from a very bad headache, and I hope that I'm doing something else so that I can distract myself from the headache, so that I try to record an episode of This Week in R. And this week we have a lot of news, so I think I will go through all the news at once, and then I will just try to demonstrate one package, and then I will have some special arrangement about This Week in R in the next 2 weeks. So without further ado, I will go through all the news of this week. And again, this is Hong Kong R User Group. We are the Hong Kong R User Group. You can still find us on Facebook. So the first thing is there will be a new version of R available next week, and which is R version 3.3.3, and with the code name and other canoe, and it will be available on the 6th of March, but the preview release is already available on the CRAN. So if you want to preview the latest version of R, you may have a look. And as far as I know, that will be the final version in the 3.3 branch of R. And we will have the 3.4 version of R later this year. The next news is there is a new repository of R package, which is called the neuroconductors. And the neuroconductor, as claimed by the website, is open source platform for web testing and dissemination of reproducible computational imaging software. So most of the package available in this repository will be about computational image analysis. And currently they have 39 packages available in this repository. And if you are a researcher in the computational imaging research, you may check it out. But after the introduction of this new repository, the R community have a very diverse opinion about the current state of affairs in the repository business. For example, Stephen Turner tweeted about it. Is the distribution fragmentation of R repos a good thing? Because now we have multiple repository of R package, namely the CRAN, the bioconductor, GitHub, RForge, the MRAN, which is the Microsoft version of CRAN, and the other, which is the neuroconductor. So now we have multiple repository, and if you need to get a repository for R, you need to first check whether the package that you want to use is available in which repository first. It may be a problem, but I have no opinion about it. So if you have any opinion about it, you may leave a comment down below. No matter it's on Facebook or on YouTube. I would like to know your opinion about it. So the next thing, the next 3 news is all about ggpod, and following the the theme of the last week. Last week, all the news. We didn't have a lot of news last week, and most of the news in last week is about ggpod. This week, we also have a lot of news about ggpod. The first is the gggraph. Okay, they have official pronunciation. Is gggraph. Okay, gggraph is ggpod extension used for plotting network graph or plotting networks. So they support iGraph, I believe. So if you're using if you have some network in iGraph and you don't like the default visualization from iGraph, you may use the gggraph to plot your network, likely using the ggpod framework. Okay. The next one is from Hong Kong. Again, is from Guan Chuan Yu, and he created a new package called a ggimage. And the ggimage is support aesthetic mapping of image file to be visualized in ggpod graphic system. So basically, what it does is to support image file and then use those image file as geometry in ggplot. So for example, you have the image file of a cat, so that you can use that cat image in a ggplot. And similarly, if you have a image of I don't know what it is, and it's maybe a bat, and you can plot it like this, and also flag and things like that. So very promising. So if you need to plot something with image file, I think the most probable usage scenario is for data journalism. For example, if you need to visualize something about country, you may use different flag and then plot it on a graph. And the next three is about a big tech company, and mostly about machine learning. So the first one is the official release of rsparkling on CRAN. So what is rsparkling? And we have introduced about H2O in the second episode, and also the sparkly R, I believe, also in the second episode, but my memory may be wrong. And now we have rsparkling, and which is an extension package for sparkly R that provide an interface to the H2O sparkling water machine learning library. So basically, it meaning that you can analyze your large big data on Spark using the H2O machine learning library. So very interesting thing. So if you have large data and which cannot fit into the memory and analyze using H2O, now you can use the rsparkling to analyze it using Spark with an interface to the sparkly water machine learning library. So very interesting thing. So I will check it out later and give you a demo of the rsparkling in the future episode. But because it's just released, so I don't have time to test it. But it seems to be a really interesting development in R. The next one is from Facebook, another big tech company. And and they released a new package called ep5, which is the forecasting at scale. So basically, it's a time series, a new method of doing time series forecasting in R. Actually, it's not just R. There seems to be a C++ library, but have bindings to R and Python, and they try to. It's an additive regression model for forecasting time series data, and they have formed. They try to decompose time series into four main components, and which is the growth curve trend, and the yearly seasonal component, the weekly seasonal component, and the user provided list of important holidays, and so that it can do a forecast using the time series data. And it seems that it is really robust in predicting what they want to do. For example, to predict the page view of some Wikipedia page, and they found it is really accurate. So if you need to do the time series forecast, so you should try to look at this package from Facebook. And last but not least is from Microsoft. Okay, another package from a package from Microsoft, and which is the lightgbm. The GBM stands for Gradient Boost Machine. So, okay, another boosting algorithm available. So, if you have followed what is going on in the machine learning scene in the world, there are two main development in the machine learning field. The first one is deep learning, okay, the latest buzzword in the IT field. Another one is boosting, and so if you have a tabular type of data, for example, you have a data frame in R, and then you want to do a supervised learning, and if you follow the Kaggle, the last few winner of Kaggle, most of them are using the boosting methodology to achieve the extraordinary high performance of their machine learning algorithm. So, and the XGBoost is the boosting framework that born from the Kaggle, and now the Microsoft also have their own boosting framework, which is the lightgbm. And actually, this package has been released since last year, but it only have the Python binding. And then earlier this year, they released the beta R package, the R version of the lightgbm. And earlier this week, they released the version 2 of the lightgbm. So in the next part of the this week in R, and I will do something special, which is introducing something as a concept. Why I need to do that? Because as you may know, we have the machine learning course later in March. So, but we only have 4 classes, and we cannot introduce everything in that class. So I will try to record something as an introduction to those students, and also to all of you. which is some basic concept about R. And the first topics that I will record is the grammar of graphics, and which is very useful for data visualization. So as you may know, okay, but most of you don't know, there are actually three graphical systems, big three graphical systems in R. The first one is the base graphics. The second one is the lattice, and the third one is a ggplot. And we will talk about ggplot multiple times in this week in R. But many people actually don't know how to use ggplot. So I want to show you the higher order concept of the ggplot, or the theory, which is called the grammar of graphics, as a concept, so that you can get the intuition of how to use ggplot to do data visualization. So, okay, where should I go? Okay, maybe here. Okay, so grammar of graphics. So what is a grammar, by the way? Okay, English grammar, Chinese grammar, language get a grammar. We usually use the word grammar in the language. So, but if you check the dictionary, the meaning of the word grammar is the fundamental principles or rules of an art or science. And for example, the English grammar. Okay. For example, a sentence which is Hong Kong is not Japan. Okay, Hong Kong is not Japan. So we can classify each word by their function. For example, Hong Kong is a noun, and which is also the subject of this sentence. Is a verb. Not is an adjective, which is used for the negation, meaning reverse the meaning of the word is. And then Japan is another noun, which is the object. Okay, so now we have the grammatical element of each word, or in this sentence, and actually each grammatical element have their own function or have their own type. Okay, because English is what we call it SVO language. Okay, so it should follow the structure of subject, word, verb, and then object order. So in order to combine these grammatical elements into a weighted English sentence, we need to follow that order. And those order and the classification of grammatical element, which is the grammar of English. Okay, this is a very typical example of English grammar. But Leland Wilkinson derived a grammar for graphics, and okay, it may seem abstract how to derive a grammar of graphics, right? It actually derive a method to how to concisely describe a graph, but it is really abstract. So Hadley Wickham, in his PhD research, he refined the idea of a grammar of graphics, and he created another system which is called the layer grammar of graphics. So a graphics in the layer grammar of graphics is a distinct layer of grammatical elements with the aesthetic mapping. Again, it is still very difficult to know what it means. But if you know what is the meaning of the grammatical elements in a graphics, and also how to map them together. That is basically what it means by the grammar of graphics. So in his definition, so there are only three essential elements of a graphics. So the first one is the data, okay, which is straightforward. So you need to have some data to plot, right? So this is the first layer, which is the data, okay. The second layer, which is the aesthetic mapping, is to the scale on which we map our data. So in short form, it's just called AES. And in a human language form, which is just like, for example, I have some data, I want the A variable, which is represent the x-axis, and another variable, B variable, which is represent the y-axis. Just something like that, okay? And the third layers, or the third grammatical elements, is the geometry, or the short form is called ggim, and the visual element used for our data. So now we have the aesthetic mapping, which is just represent the scale of the graphs. Now the geometry is how to represent your data on such a scale. For example, I want to have a point. So for example, each point represent one data. So that geometry will be a point, okay. And sometimes the geometry can be a line. So it will be a straight line or a curve and something like that. And with these three elements, we can construct a graph. And there are actually more grammatical elements. There are additional grammatical elements such as the facet, statistics, coordinate, and theme. These are the additional grammatical elements, but as an introduction, I will only introduce the first three elements, which is the data, the aesthetic mapping, and also the the geometries. So, for example, we have a data set, which is the built-in data set in R, which is called the iris. And I will just use a random sample of 10 rows from the iris dataset. So the iris dataset actually have 5 variables: sepal length, sepal width, petal length, and the petal width, and also the species. So it's actually a dataset of some flowers, 3 species of flowers. So now I want to plot a graph like this, which is the x-axis is the sepal length, and the y-axis is the sepal width, and each dot represents one flower or one cases in the dataset. Okay, so this is the example that I will give you a graph and then you derive the grammar. But in the actual situation, you should have the grammar and then you have the graphs. So, but as an educational purpose, in order for you to develop an intuition about how the grammar of graphics works, so I will give you a graph so that you can have a visualization of how the graph will look like, and then you derive the grammar. So we are just doing the reverse procedure of how to do the visualization in R. So we need to describe the previous graph with English. So in the previous graph, if we need to describe it with English, so which is we are plotting the iris dataset, okay, and then we map the x-axis being the sepal length, and the y-axis being the sepal width, and each case represent as a point, right? So we have the highlighted words, which is the iris data set, which is basically your data, right? And we map something. We map some variables to something on a graph, right? We map the sepal length to the x-axis and the sepal width to the y-axis. Those kind of mapping is actually the aesthetic mapping. So this is another layer or another grammatical elements in the grammar of graphics lingo. And finally, each case represents as a point. So as a point, which is the geometry. Okay, so if we represent it as a grammar of graphics, once again, the data is the iris. The aesthetic mapping is the x-axis equal to the sepal length, the y-axis equal to sepal width, and the geometry is the point. Okay, that is the grammar of graphics. How to describe this graph using the grammar of graphics. So, in order to translate such a graphics into ggplot so that you can plot such graph in ggplot, so we basically just transform the previous grammar into a ggplot command. So ggplot, the first argument is your data. The second argument is the AES, which is the aesthetic mapping. So you just tell ggplot the x-axis is the sepal length, y-axis is the sepal width, okay, and then plus another layer because the point layer or the geometry layer is on top of the data and the aesthetic mapping. So it should be plus the geom point, so that using this command, we will create a chart like this. Okay. This is another example, so which is just a variation of the previous plot. So now we have the same plot, basically the same plot. The only difference is now we are representing the color of each point by the species. There are 3 species in the data set: the setosa, the versicolor, and the virginica. So each point represents different color. Okay, so actually using the same intuition, you will know how to describe it into the grammar of graphics. So the first step is to describe it in English. Describe this graph in English. So this is the previous description. Okay, iris data set, x-axis being the sepal length, y-axis being the sepal width, and each case represents a point. So the only difference is the color, right? But where should the color goes in this English description? So we need to think what actually is the color doing, or how we do with those color. So is it related to the data? It's not, because the data is the iris data set. It already have the species data in it, and it didn't have any information about the color. Each case represented as a point. Okay, still each case is still represented as a point. So okay, using the method of deduction, we know that it should be in the aesthetic mapping. So we are actually mapping the species into the color of each point. Okay, so it should be go into this sentence. So we are actually adding just one thing. So we map the x-axis being the sepal length, y-axis being the sepal width, and the color being the species. So now we have a complete description of this graph using the English. Okay, so now we can translate this description into ggplot, okay, by just adding one more element in the AES, which is the color equal to the species, and then add a GM point, and then we will have a beautiful graph like this. So we have another data set. So this time it's not iris, so the data element should not be iris anymore. So now we have a data set called pressure, which have only two columns, which is the temperature and the pressure. Okay. So now we want to represent this graph into the grammar of graphics. So we have the x-axis being the temperature, the y-axis being the pressure. So we are actually describing the aesthetic mapping. But this time it is not a point, okay? This time it's a line. So the geometry is different. The only difference is the geometry, okay? So if we need to describe the previous graph into English, which is we are plotting the pressure data set, the data equal to pressure, and we map the x-axis being the temperature, y-axis being the pressure, and all cases represent as a line. So this time it's not point, so the geometry is different, so line. So if we need to represent it as the ggplot command, that will be ggplot, the data being the pressure, and then the aesthetic mapping, x being the temperature, y being the pressure. And then this time we are not adding the GM point. This time we added GM line, and then we will have a line graph this time. Okay. This one is tricky, but so now actually the graph is the same. The only difference is now we have the line, okay, together with the point. So now we are representing each case as a point and line. So if we need to describe it into an English sentence, which is we are plotting the pressure data set, we map the x-axis being the temperature, y-axis being the pressure. So the data and the aesthetic mapping is the same, okay? The only difference is on the geometry. So all cases represent as a line and points, okay? So in the next command in the ggplot, the data should be the same, the aesthetic mapping should be the same. The only difference will be the geometry, okay? But how to represent the lines and the point at the same time, okay? So ggplot is a very smart framework for doing the data visualization. So I hope that you can imagine how it works. So it actually using the same data, using the same aesthetic mapping, even the GM line, which is the geometry of line, is the same, but we add one more layer, one more grammatical element to the command, which is a GM point that you have learned in the iris dataset, and then you will have a graph with the lines and a point. Okay, so I hope that this exercise helps you to develop an intuition of how the grammar of graphics work. So actually the intuition is you need to describe it as describe a graph in English first, using the framework of the grammar of graphics, which is what is your data. The second step is the aesthetic mapping, how your data will be mapped onto as a scale on a graph, which is usually the x and y axis, and also the color, and maybe sometimes the alpha, meaning the how dark of each data set, also the size and even the size of how each data will report on a graph. And then finally is the geometry, which is how your cases will be represented on such a graph. It can be a line, it can be a point, sometimes it's a ribbon or a bar chart, so it will be GM bar, something like that. So if you can think about your data visualization using such a framework, and then you will be able to use the ggplot more efficiently.